Okay, in this chapter, we will cover week 4, data link layer. Week 3 was about physical layer. Okay. So data link layer is which layer in the OSI model? It's layer 2. Right. So we will learn about the objective, the functionality, the functions, the responsibilities of the data link layer and its role in WAN networks also. So the data link layer, it's responsible for communication between end devices interface cards, between the network cards of the hosts or the end devices. They communicate, controlled by data link layer. Data link layer depends on the physical address. Okay. And the encapsulation in data link layer is called frame. Okay, you can write note of this information. Okay. Also, data link layer performs error detection and rejects corrupt frames. Okay. The data link layer is functional or important for your subnet or for your local area, for your own subnet, because it will help each host to communicate with the host in the same subnet. All right. However, we'll still require it for transmission of data outside of your subnet. The data link layer creates a logical connection between nodes on the subnet. If the data is distant for a device within the same subnet, we have no problem. The link is there because it's creating the connection for if it's in the same subnet. Okay. If it is outside the subnet, the data is sent to the gateway, the default gateway or the router. All right. And the protocol data unit or PDU is frame. So these are important. So we can summarize the responsibilities of DL layer: placing the data onto physical media or the cable or the wireless, error notification and flow control. The error notification is carried out through the use of a checksum that includes the trailer that's added to the data. So for the error, it is added to the trailer, not header, in the trailer. By the way, data link will add header and trailer. Data link will add header and trailer. Very important layer. Checksum is in the trailer. The data link layer has two sub-layers. And if you look here, the data link layer has two sub-layers. The one on top, which is near to the network layer, it is called logical link control, LLC. It acts as an interface with the network layer and identify what network layer protocol is being used, such as IPX or IP, and it stores that information within the frame header. This happens so that when the data is received at the other end, the device knows which network layer protocol is need to send. I think this is clear, right? So it is close to the network layer. It will identify the network layer protocol. For example, is it IP or IPX? Okay. The lower layer is called media access control. This is more close to the physical layer. MAC. The MAC sublayer is responsible for controlling how the data is put onto the certain media or how we control the data access to the media. The MAC sublayer can be occupied by a number of protocols. For example, 802.3 Ethernet or 802.11 Wi-Fi. All right? So please remember these numbers. 802.3, this is for Ethernet. And 802.11, this is for Wi-Fi. We have other numbers for WiMAX and others. Okay. So this is the data link. It's split into LLC and MAC. The LLC is 802.2. The MAC sublayer, we have the Ethernet, the wireless LAN, the wireless PAN, the personal area network, and this is the standard IEEE 802.15. And then we have various Ethernet standards for fast Ethernet, gigabit Ethernet, and so on. We have also various wireless WAN standards for different types of wireless communication. And we have various PAN standards for Bluetooth, RFID. Okay. You know the RFID, the codes. Okay. RF, radio frequency identification. Media access control, providing access to media, so the packets are exchanged between nodes, may experience numerous data link layers and media transmission. The router will do the routing for the packets, depending on the what? Depending on what the router? Very good, IP address. The data link layer, depending on the MAC address, because it's in the subnet. Very good. Very good. So, router will accept a frame from the network medium, de-encapsulate the frame to expose the encapsulated packets, re-encapsulate the packet into a new frame, forward the new frame on the medium of the next network segment. This is the router. We will see this recording at the end. Physical and logical topologies. The topology of a network is the arrangement and the relationship of the network devices and the interconnection between them. So we have two types of topologies. We have physical topology. It shows physical connections and how devices are interconnected. We talked about this when we talked about physical diagram and logical diagram. Logical topology, it identifies the virtual connections between devices using the device interfaces, IP addresses. So I'm not talking in the logical, where is my router placed, in which room. I am talking about how we are building our network, the virtual connections, okay? WAN topologies. We have three common WANs. Point to point. This is the simplest one and most common. It consists of a permanent link between two endpoints. So one company, they have two branches or two head office and another main branch. They can have the point-to-point link. That's very fast, very secure. They control it, but it's expensive. Then we have hub and spoke. This is similar to a star topology where a central site interconnects branch sites through point-to-point links. Hub and spoke is like there is one central and there is two coming out. You know the spoke? Then we have the mesh. Mesh is the most expensive but most redundant. Here you have high availability but requires every end system to be connected to every other end system. And everyone is connected to each other like a mesh. Okay. Point-to-point topologies directly connect two nodes. This is the point-to-point. They may not share the media with other hosts because all frames on the media can only travel to the two or from the two nodes. Point-to-point WAN protocols can be very simple. Why? Because I'm sending from this node to this one. We have our own connection. Okay. LAN topologies. This is a physical topology of LAN. It's called star. You have a central point here, device, and they are connected to that device. Here we have extended star. I have central. They are connected with a backbone cable. This one is called bus topology because they are connected serially on the physical cable. What's the problem with the bus here? Can you look at it? What's the problem? Who can tell us? What is the problem here, you think, with this type of topology? If this cable is cut, they are all cut. They are all cut off, correct? Because they are all placed on the same, like serially. So if the cable is cut, all are disconnected. But here, if this cable is cut, only this laptop is not connected. Bus topology, this was used by IBM. It's like this. If each laptop will wait, each connector, each end device will wait for a token. When they receive the token, they can transmit. Then the token is going to the other device, or the other device. So it's called token. It's an old way. With the bus, all end systems chained together and terminated on each end. Ring, each end system is connected to its respective neighbors Okay. So again, the access control methods, we have contention based, which is carrier sense multiple access with collision detection. If there is a collision, each node will wait for a random time before they transmit again. The second method, so the CD is the legacy one. The newer one is collision avoidance. Before the node sends, it will listen to the line and see, is there anybody else transmitting? Nobody is transmitting, then it will transmit. Okay. Control access or controlled access, this is deterministic. Each node has its own time on the medium. Now, this was used in the legacy network, such as the token ring and ARCnet. So a node will send only when it has the token. Okay. The CSMA collision detection used by legacy LANs. It operates in half duplex, and we already explained how it works. The collision process, devices transmitting simultaneously will result in a signal collision on the shared media. So these devices will detect the collision. They wait a random period of time and retransmit data. And this waiting period is calculated. There is some equations. People, they have done extensive research how to find out this random time or to calculate this random time. The collision avoidance, it's used by IEEE 802.11 wireless LANs. Okay, because we know that wireless LAN, we are sharing the same media. Collision avoidance process, when transmitting, devices also include the time duration needed for the transmission. Other devices on the shared medium receives the time duration and know how long the medium will be unavailable. How about that? Okay. The frame is the data unit in the data link layer. It has header and trailer. Data link frame has three parts: header, data, trailer. The fields of the header and trailer may vary according to the data link layer protocol, according to your protocol. Their size will be different. The amount of control information carried with the frame varies according to access control information and logical topology. We already mentioned this. Okay. Now, this is high-level information. Yani. We can go very deep into this, but in your telecom class. But for this class, we need to know this basic information. All right. Any questions here? Okay. This is your frame. These are the fields in your frame. We have the header. The header has frame start, addressing, type, and control. The packet or the data is the data. What you receive from your data link, from your network layer. The trailer, we already mentioned, trailer has what? The checksum, error detection, and it has the frame stop. Okay. The layer 2 address or physical address, it is contained in the header. It's used only for local delivery of frame, updated by each device that forwards the frame. Okay. The logical topology and physical media determines the data link protocol used. We have Ethernet. We have 802.11 wireless. We have already mentioned that. the point-to-point, the high-level data link control or HDLC, and we have the frame relay. Each protocol performs media access control for specific or specified logical topology. Any questions? So this is the end for this chapter. In next lecture, we will cover the Ethernet switching. So let me ask you some questions.